have this layer of granulosa cells that's pretty much kind of associated with the egg. They're kind of surrounding the egg. That's going to eventually form what's called your corona radiata. So when you go through ovulation, all of that is going to be released around the egg. That kind of forms like a protective layer around the egg. Alright, and then these are your granulosa cells. So this entire layer here is your stratum granulosa or your zona granulosa. That's it, yeah. Alright, and then the outer connective tissue layer, that's your theca. And the space in here is your antrum. Alright, so that's secondary. And so inside the secondary, it's still your primary oocyte. Okay, we still call it a primary oocyte. It doesn't get to, we don't call it a secondary oocyte until it's actually about to ovulate, because it's still stuck in the first phase of meiosis here. So it doesn't actually continue through that phase until the egg becomes fertilized. Then it continues with the whole process of meiosis. Oh, here's a good primary. Alright, so this is a good primary. We have our primary oocyte here. We can see a little bit of the nucleus here, and then we have a single layer of granulosa cells surrounding the egg. So that would be a primary follicle. Alright, so once we have ovulation, the egg is released. You have your granulosa cells are going to remain, as well as your theca cells, and they form a structure that's known as your corpus luteum. Alright, so that literally means yellow body, as in the first dissection, when you cut it, it looks yellow. Alright, so this huge structure here, this is actually the corpus luteum. Alright, so again, these are cells that are producing hormones. In the corpus luteum, it's mainly progesterone that's being produced. And that's going to remain for a couple days. If the egg becomes fertilized, it remains in the ovary producing the hormones. If the egg is not fertilized, then it's going to regress after a few days and form what's known as your corpus albicans. Alright, so these large cells, these are your luteal cells or your lutein cells that are sitting in the corpus luteum. Alright. So notice they kind of look, I don't know if you can see too well, but they kind of have that foamy appearance because they're secreting these steroid hormones. So remember, those are lipid-based. So once the lipid is extracted, you kind of get this foamy appearance of the cells. Alright, so these are your lutein cells that are found in your corpus luteum. So that huge structure, that's your yeah, once an egg is released, you have a corpus luteum being formed. So for instance, in the cat ovary, you have a few reproduced each month. They remain for a few days. If the egg isn't fertilized, they start to regress, they start to degenerate, and it eventually just forms scar tissue. So that will remain for a pretty long time, I guess. Yeah, the corpus albicans. Alright, so
A wad of gum analogy.
Hmm?
A wad of gum. It looks like the albicans.
Yeah.
It's almost like somebody took the ovary and stuck a wad of gum in it because it's all weird shaped and it looks like a squished piece of gum on the ground.
Okay. So this is a scanning view of the ovary. This is a senile ovary. So you have all these corpus albicans here. This is one here. That's another one. Alright, so notice with this ovary, if we look along the periphery, we're really not seeing a lot of primordial follicles or primary follicles. So pretty much, you know, this person has gone beyond all that. More eggs.
Menopause.
Alright, so you have this structure here that's formed, and it's there are not a lot of cells present in there, so it's pretty much just scar tissue. You have very few cells, very few fibroblasts present. You can see a few nuclei sitting here, but it's mainly just collagen fibers. It's mostly fibrous tissue, so you're not seeing many cells as we saw with our corpus luteum. All right, so that's your corpus albicans. That's one there. There's another one here. So here's another huge one. There's another one here. All right, so once you're seeing a lot of those corpus albicans, that would be the senile uterus, the senile ovary, sorry, where you don't have much taking place. All you have left on it is pretty much just this scar tissue. All right, so okay, so once the egg is released, it goes into the fallopian tube, or the uterine tube, or the oviduct, same thing. Alright, so the oviduct, it's a single tube, and notice you have a lot of the mucosa, you have a lot of infolding in the mucosa. So you see this kind of characteristic look of the uterine tube. The shape of the lumen kind of changes as you go through different parts of the uterine tube, but pretty much you have that, you know, you have a lot of folds inside it. So notice you have all these folds, and it doesn't really have a characteristic pattern like you would say, you know, star shape or U shape like we saw before. But once you see that kind of infolding, you know that's our uterine tube. So this is pretty much just a low power ID, and it's going to be identify the organ, identify the organ. Alright, and if we look on this slide, you have these structures that are projecting outwards. These are the fimbriae. So those are finger-like projections that you see surrounding the uterine tube. They're not on all the slides, but you'll see them sometimes on the slide with the ovary. So once the egg is released, you have these little finger-like projections that are there to catch the egg and kind of guide it into the uterine tube. Alright, so those are your fimbriae. So that's ID the structure, I think. Alright, so you have all these little projections here. These are all your fimbriae. Alright, and again, that's our uterine tube. Alright, so this is at low power. We're not going to go below low power for that. So for that one, you want to pay close attention to the scanning view. Once you see that kind of characteristic pattern at scanning view, you know that's your uterine tube. And then you have a little bit of smooth muscle and connective tissue surrounding it, but there's no, you know, characteristic layer or pattern that you're looking for, except for the lumen. Alright, so this is our uterus. So the uterus is going to go through different phases, you know, through the month. So as the hormone levels change and, you know, all that stuff happens, we go through different phases. So you have three basic layers. You have your endometrium, that's the innermost layer, so that's facing the inside of the uterus. And then you have your myometrium, which is the thickest layer, so you have a lot of smooth muscle present within that layer. And then the perimetrium, which probably it's not always present on the slides, but it's going to be kind of a similar to the serosa that you saw in the GIT. You just have a single layer of simple squamous cells lining the outside. So this one was actually cut through the myometrium.